Okay, everybody get your Frayer model out. You're supposed to get together your definition for 4 words for section 3.2, linear functions. So our goals for today are to figure out linear functions, to identify whether it's a linear function or a non-linear function. We're also going to look at the domain itself and to identify whether it is a continuous domain or a discrete domain. So I asked you yesterday to fill out the Frayer model for 4 vocabulary words. So I want you to get yours out, and we're going to kind of compare yours, and we're going to put them all together. And I'm going to invite you to make any changes to yours or add to them as we go through them. So the first word we had was linear function. So what's the basic definition of a linear function? Who can tell us what that is?
Function's graph that is a non-vertical line.
Okay? So it's a function. And from the definition we did the other day that's a function, somebody remind me what that is. In order to be a function, what does it mean?
Has to have one input value, one output
Yep.
value.
For every input, there's exactly one output. So we already know what that was. So it's a function that does what?
That has a vertical line.
Creates not a vertical line. Yep.
Non-vertical line.
Does everybody know what non-vertical means? Okay, vertical is straight up and down, so it can be anything but straight up and down. Okay? Did anybody find any facts or characteristics that were important about a function, a linear function? Go ahead.
It has to have a straight line.
Okay.
Or has to be straight.
Okay, has to be a straight line.
I just said it can't be curved.
Okay. So I just heard somebody else say that it can't be curved, so it can't have any bends in it, can't have any jags in it. It has to be just always a straight line. Yep. So however you put that in your facts or characteristics, that's fine. Anybody else have anything else that they put in their facts or characteristics? Go ahead, Paige.
Has a constant rate of change.
Yes, I like that a lot. Has a constant rate of change. So that means it's always going up or down by the same amount. So it's always increasing or decreasing by the same amount. So like in a real life situation, like if you have a job, if you're getting paid by the hour, you're always getting paid by the same amount every hour. That would be a constant rate of change. One thing that this particular section didn't talk about, but I know that it's coming down the line in this section, so I want you to add to this, because I know it's coming, is it can be written in y equals mx plus b form. Do you guys know what that means, y equals mx plus b?
No.
That's something we're going to talk about later. That's something called slope-intercept form.
Y equals
mx plus b. can't read it very good. Y equals mx plus b. And I'm kind of jumping ahead, but I want you to include that so that you have it later. That's something called slope-intercept form, and we're going to be talking about it in this chapter. So I just want you to include it now so we don't have to add it later. And if it's a linear function, it can be written in slope-intercept form. So what kind of examples did you guys put?
I just put like a.
Yeah, the one I like a graph.
So you guys did a graph, okay.
Yeah.
And what did your graphs look like?
Yeah, like that.
And then I did a straight line.
You just did a straight line,
Yeah.
like a diagonal?
Yeah.
Okay. And since I jumped ahead and put that equation in there, I want you to include an equation. So y equals 3x plus 5. That is an example of something in slope-intercept form. And y equals -2 would be another example. So then what are your non-examples?
I did a
I did
graph.
Okay, another graph.
Like a curved line.
Yeah. and
Curved
I did a
line?
Curved line too.
They're also going to throw some equations at you in this section. So I want you to include some of those. If you look on my bulletin board over here, it has some different forms of equations. I want you to notice that over here there's something called a quadratic equation, and it has a power of 2. Do you see this? That has a parabola. Is that linear?
No.
No. So anytime you see a power of 2 in your equation, that's never going to be linear. Last chapter, we did things, what are these symbols called?
Absolutely.
Absolute value.
Wait, do you want some example or non-example?
These are on the non-examples. If you look over here again on my bulletin board, this has absolute value. What does that graph look like? Those are V's. Does that make a straight line?
No.
No, so this would be nonlinear. So if you come across an equation, you should be able to look at that right away and say, if it has absolute value, it's going to be, is it going to be linear?
No.
Nope. So there's a couple extra examples. Another example that I'm going to help you out with is it says non-vertical, right? Anytime you have a plane X and a number, that's a vertical line. So x equals 3 or x equals 2 or x equals -5, that makes a vertical line. So can that be a linear function?
No.
Nope. So all of these would be non-examples. So you might want to add those to yours. Any questions? Anything else we need to add to linear functions? Okay? Moving on. What was our next word? Nonlinear. Okay, so it's a function that does what?
Have a constant rate of change.
That does not, say it again. I heard it, but I didn't.
Does not have a constant rate.
Okay? Anybody want to add anything to that or change anything? Do we all agree? Is that what you guys have, pretty much?
Yeah.
Okay. Any facts or characteristics about this one?
Not a straight line.
Okay.
Is not changing frequently, or does not change frequently.
Say that again.
Is not changing frequently.
It's not changing frequently. You don't give me more info.
I don't know how you say it.
You talking about the rate of change?
Yeah.
Okay, we talked about rate of change
It's
here.
not varying very much.
So the rate of change varies, is that what you're saying? Is that what you
I don't know.
read what you have one more time?
It's not right.
No, it could be. Help us out.
I don't know.
I think you're saying the rate of change varies. That's what I heard. Because wouldn't that be right? Because in this one it has a constant rate of, in the first one it has a constant rate of change. In this one, you might go up by 2 for a while, and then you might go up by 5 for a while. And I think that's right. Right? Don't you guys agree?
Yeah.
Absolutely. Isn't that what you mean? Tell me if I'm wrong. That's what I heard. Anybody else have anything? Okay, what kinds of examples did you guys have?
A graph with
Different kinds of graphs? Somebody describe your graphs to me.
Yeah, I like that. That's what I did.
And then like
Curves?
a bit.
Okay. So I'm just gonna do some. Is that linear?
No.
That's pretty non-linear, isn't it? Then you could do a couple of equations. If I threw the square root in there, would that be nonlinear?
Yeah.
Yep. Could I just have flip-flopped these around in my first one for these?
Yeah.
Yep. So my non-examples would be a line, right? And a linear equation. Okay, before we get into discrete and continuous domain, I need somebody to remind me what domain is.
The input values.
The input values. So we're talking about input values in both of these. So if we're just concentrating on discrete domain, somebody over on Carter and Megan's side of the room, what did you guys think discrete domain was? What was the definition you guys came up with?
Set of input values that contains only certain numbers in an interval.
Okay? So it's the input values. That are only, I'm going to shorten it up just a little bit, that are only certain numbers in an interval. Does anybody know what that means?
Like,
What is that even talking about?
it's
Megan?
It's like specific points in the number line.
Specific points on a number line. I agree with that. Specific points on a number line. Anybody have any facts or characteristics? Is that was one of your facts or characteristics, Megan?
Oh, yeah.
Okay. Specific points on a number line. Okay. What helps me understand discrete and continuous is if I think about real-world applications. Discrete. Discrete represents things that represent whole numbers or integers. So think about, okay, when you go to the grocery store, if you are shopping for cans of vegetables, can you buy whole cans of vegetables, or can you walk down the aisle and say, I only want 5.7 cans of peas?
No.
No. Can you say, I want 2 3/4 cans of peas today? Do you have that option? No. So you can only buy whole cans of peas. If I went around and polled you and asked you, how many DVDs do you guys own? But could you give me a number? Would they all be whole numbers?
Yes.
No.
So you can own part of a DVD,
Yeah, we've broken a couple.
but do you still own it?
Yeah, but it's half of it.
Well, then you don't, then it's probably gone.
Probably.
Yeah. Okay? So you either own it or you don't, right? They're wholes, right? So if I am graphing things, like if I was graphing how many students are in this class and how many students are in Mrs. Detman's class and how many students are in Mrs. Kruko's class, aren't they going to be whole numbers?
Yeah.
Yeah.
There isn't going to be half of a student here, 0.4 of a student there, 0.9 of a student there. They're whole numbers. Those are discrete numbers. They're whole numbers. We're not talking of parts of numbers or fractions or decimals. Those are discrete data. Because we're talking about specific amounts. So if I was going to graph that information, they would just be specific points on a number line. They are discrete. So you use discrete domains in situations that you need whole numbers or integers. What's an integer? Yes, you know. What's an integer?
Number.
Like,
Negatives.
Negatives. Whole numbers and their opposites.
Yeah.
Yep. So for situations that you're not going to need any fractions or decimals. So that's when you're going to have a discrete domain. So with the discrete domain, you're only going to have points. So for example, number of DVDs. Because that's going to be a specific number. You're going to have 13 DVDs or 12 DVDs. Like if you're in a club and you joined a club and you're going to buy two DVDs every month. So isn't that going to go up 2 DVDs every month?
Mm-hmm.
So you're going to go up 2 DVDs every month. So it's going to go up 2. But you're only going to have specific points. It's going to go up 2, 2, 2, but they're going to be points. So your graph would just be points. Now let's skip that non-example, because what can we put in a non-example?
continuous.
The continuous. So let's skip over here and let's figure out what a continuous domain is. So what's the definition of a continuous domain?
Set of input values that contains all numbers and intervals.
Okay? So it's input values that are
Like between between certain numbers.
I like the word all,
Input
That
values that all.
are all numbers. So if it's all numbers, what does that mean?
Every number in between.
Every number in between. So that means it's going to be whole numbers, integers, what else? Decimals and fractions.
You put all twice.
I like the word all.
I know, but input
I like it
values-
so much I wanted it twice. So should we put that in facts and characteristics? So what should we put?
I said on
Includes what?
Fractions,
Includes fractions.
decimals.
So let's go back to that supermarket. If you go up to the meat counter, can you say, I would like 2.5 pounds of hamburger? Can you say, I want 2 3/4 pounds of hamburger? So you can say, I want parts of the hamburger. You don't have to say, I just want exactly 4 pounds. So you can have things in between, right? Okay? So you can include those fractions and decimals, right? Okay. So this would be the things that you keep track of. And so what kind of a line on a graph would this be?
And full.
A full line. So what is it going to look like?
Shaded in between.
Shaded in between. So there's your solid line. So if I know they raise fish out in the ag building. I don't know if they measure them or not. But let's say the length of fish out in the ag building. I would assume they would measure them as they grow. Aren't they going to chart that and measure them as they grow? And keep track of them? So that's going to be a solid line. So that's going to be continuous. So do you see the difference between discrete
Yeah.
and continuous? So can you flip-flop those for the non-examples?
Mm-hmm.
Okay. So a non-example is going to be a solid line for discrete, and a non-example for continuous is going to be what?
Dotted.
Specific points.
Specific points. Because you're talking about specific numbers, specific information. So, for example, if you are documenting the data over time of the height of a tree, would that be continuous or discrete?
Continue.
Continuous. If you are documenting how many pencils, the number of students each student has in the classroom, discrete. All right. Got that? Any questions over the vocab? Okay, put that away and get your notes out.